We're all familiar with tablet computers these days, but in the early 90s, Apple developed a predecessor to the iPad that never really saw the light of day. Until now. It's been said that history doesn't exist as a straight line, but rather an interconnected web of events. In the late 1980s, Apple was firing on all cylinders. Desktop publishing was a huge market, and multimedia was just on the horizon. But within the company, teams were at work exploring a world beyond just desktop computers. In 1989, Apple launched its first portable Mac, aptly named the Mac Portable. But it was big and heavy, garnering the nickname the Mac Luggable. The public was a bit skeptical of Apple's ability to deliver a truly mobile computing experience. What nobody knew, though, was that incredible things had already been done. And the best person to explain it is someone who was at its epicenter, Tom Gilly.
I was a Mechasoftronic engineer, is what I called myself, Mechasoftronic, so mechanical, software, hardware engineer. So I did mechanical systems, software systems, I wrote code, I did chips, so kind of a jack of all trades. My group was the group that looked at the near-term horizon. Mine was the concept integration lab. So it was, what are the advanced concepts coming out of ATG that could be prototyped into a concept, like a concept car?
Not all ideas from the Advanced Technology Group, or ATG, made it into products, of course. But some important ones included the Apple QuickTake digital camera, HyperCard app development and database platform, and most notably, the QuickTime multimedia software. One project Gilly worked on was to cram as much technology as he could into as small a footprint as possible. This was largely done by reducing the number of chips on the motherboard by leveraging programmable ones known as FPGAs.
And what you see here is one of the first hardware projects coming out of the Concept Integration Lab, the first iteration of the board that allowed us to do reconfigurable computing. So it was a research into reconfigurable computing. And then it worked so well, we ported the Mac operating system. And we got it to work. And we created the first handheld portable Macintosh.
These not quite complete computers garnered the term Smart Information Artifacts, or SmartArtifacts for short, and their development pushed the boundaries of what a computer actually was or what it could look like. The majority of prototypes, mock-ups, and concept models were usually destroyed by Apple when their purpose had been fulfilled, but inexplicably, a collection managed to survive. One example is a prototype portable multimedia player codenamed Sweet Pea that Gilly whipped up. It had a monochrome touchscreen LCD and speaker and used CD-ROMs as its media. Since portable optical drives were in their infancy, he modified a Sony Discman instead. It was ultimately wrapped up into a joint venture with Toshiba that would leverage technology from an Apple spin-off company called Kaleida, though it never made it to market. Apple CEO John Sculley was all in on technology like this, and even outlined a concept he called the Knowledge Navigator, which the company created a series of videos to explain.
Let me see the lecture notes from last semester. No, that's not enough. I need to review more recent literature. Pull up all the new articles I haven't read yet.
Your friend Jill Gilbert has published an article about deforestation in the Amazon and its effects on rainfall in the sub-Sahara.
But keeping with a traditional keyboard and mouse interface on a handheld device wouldn't work, so Gilly and his colleagues in ATG explored alternatives. By 1990, development was well underway for proper Macintosh laptops to be called the PowerBook, and these would prove to be the foundation on which ATG would build a new project. In the late 1980s, laptop computers were still in their relative infancy, with lots of work left to do when it came to miniaturizing components and making them truly portable. Keyboards and pointing devices were a necessary part of the package, and often dictated the size and shape a notebook would take. But this, of course, wouldn't work with a handheld computer. Another input method would be necessary.
I started at Apple in '88 working in what was called the Human Interface Group, which, basically was in charge of the Finder and sort of apps that Apple might offer as part of the basic package.
This is Tom Erickson, who was on a team that set out to see how the inclusion of a touchscreen could make portable computing better, through a project codenamed Scribe. The team didn't want to just retrofit the Mac interface to work without a keyboard or mouse, though, for one good reason.
Handwriting recognition sucked, as did speech recognition. I mean, the people who worked on it, they were really pushing the envelope. They were doing pretty amazing things with the technology. They could say, oh, we're the best in the world here or there. But when you sat down and had people actually use it, it wasn't good enough. You can do the best stuff in the world, and it's not good enough. And I and probably quite a few of my colleagues in, human interface were skeptical of, could it be good enough for people to really want to use or to be useful, right? How many, if you're writing a sentence and, it gets 90% of the characters right, but ends up getting, you have a mistake in every sentence, that may not work for people who are just trying to do their job and aren't impressed by the technology.
This presented a unique opportunity. What if, instead of you doing the work on the computer, you told the computer what work to do for you?
From the very beginning, Mac and also Lisa, there had been this notion of what's called direct manipulation, right? Direct manipulation is where the user does everything, right? You do it, you want to, make a square, you use a tool, you put it on the screen, you draw it out, you see it happen, right? And that was a very powerful thing. And the Mac had always been very focused on, make everything as much as direct manipulation as possible. Well, Scribe was an opportunity to explore a complementary paradigm called delegation. And that's where it's not the human using tools, it's the human telling some kind of entity to do something for the human.
As a result, the user interface became critically important in not only overcoming the hurdles of what touchscreen technology was capable of, but also making the concept of delegated tasks easy to understand.
Often the way we started out in designing stuff in the human interface group is we would look at stuff in the physical world. We'd look at analog stuff. Some of us, and I was one of them, were big users of notebooks. And I did things like, I had a little to-do list it was kind of a diary, right? A little to-do list at the start of every page. I had little icons for meetings, or if I had to telephone somebody, I'd draw a little telephone, and nothing astonishing. Just you develop a little bit of a few symbols you use that help you scan through the paper notebook. So we sort of took that thinking and described, because there are a lot of things in paper notebooks that people are still going to want to do in an electronic notebook.
Scribe's UI logically leaned towards skeuomorphism, resembling a notebook with pages and tabs you could flip through. But without something like handwriting recognition, the task fell on the team to come up with alternatives for managing information.
You still need to define stuff, right? In my own paper notebook, I would use paper clips to mark pages that I thought I might want to go back to. And if you look at the prototype, we've got a little paper clip icon. I don't know if it made into the final version or not, but a bunch of these things, were check boxes for to-do lists were just imported directly into Scribe. And so, the idea is, okay, you write down a phone number in a meeting. Text recognition may well get one of the numbers wrong. You really want to be able to see the original thing, right? We started out with the idea of just having these icons that showed up in paper notebooks, but then at some point, one of us, or many of us, who knows, came up with the idea that, we can take this phone number stamp and we can drag out the bitmap that includes the phone number. So now that we can pull all the bitmapped phone numbers into a list, or we can search one by one.
This proved to be quite the clever workaround to the handwriting recognition problem. You could attach different stamps to information, then easily call up all the places you had used a particular stamp when you needed to find something. There were even provisions for creating custom stamps.
We started thinking of stamps in terms of, well, not only can stamps show you an area of the screen that's a bitmap, they can actually have scripts or code attached to them.
The UI also found itself surprisingly flexible in the ways you could organize information.
On one end of the spectrum, there are people who like things totally organized. So they get an email and they file it, or you get a fax and you put it in the right folder, and you have a very fine-grained folder system, and so on and so forth. And then at the other end of the spectrum, you have people who they don't do anything. Stuff just comes in and they kind of set it near where it came in. And the interesting thing I learned from the study is that people who are hyper-organized can find stuff really, really quickly. They're fantastic at retrieving stuff they need, except when they get overloaded. And when they get overloaded, everything falls apart and they don't know where anything is. Whereas the people who just let stuff pile up, they can't put their hands on the right fax, in 5 seconds, but they can do it in a minute because all the faxes they've ever received are in a pile, kind of chronologically ordered. And coming out of that, we said, okay, well, we just have to accommodate this whole range of styles.
If you didn't want to hyper-organize your information and stamp everything, it was as simple as flipping through the pages as if it were a paper notebook.
Exactly. And then you can accommodate stuff in the interim, like there was a paperclip notion where you could essentially, fold over a page, except it was a paperclip, and that's kind of intermediate, right? It's not, you don't have to figure out which category does this go in. You just say, oh, well, I may need to get back here again.
There was one problem, though. Touchscreen technology up to that point had relied on the use of a stylus, but some actions in Scribe's UI, such as flipping to another page, didn't translate to that very well. And so, the hardware needed to catch up to the software. And that's where Tom Gilley's team came in. Scribe's hardware experiments began with a touchscreen LCD driven by a Mac SE desktop, but quickly progressed to standalone devices.
This was the first portable unit. This was made from the Mac Portable. We used to call that the Luggable. It had the gel lead acid. It weighed maybe 16, 17 pounds. We just took the motherboard of that. You can see it's like a pizza box.
This one used a touchscreen from a company called Microtouch, though throughout the project, many other vendors would get involved. Building that prototype also gave Gilley the chance to work on a task completely unrelated to Scribe.
The same battery system that we put into the Mac Luggable so that it could go on the space shuttle.
A modified Mac Portable, made to fit NASA's requirements around batteries and power handling, flew aboard Space Shuttle Atlantis on August 2nd, 1991.
It's ugly here, but one of the nicest tablets that we had was AT&T. So that was it's an ugly board, but it was just a prototype. But that was 10-finger, capacitive, and it also worked with a stylus. It's much like the phone tablets that we have today.
The level of detail that went into the touchscreen extended as far as the specifics of the glass itself, which contained tin oxide sputtering.
We did that to change the index of refraction so that fingerprints don't show up on it easily. And then it gave it a texture for the nib of the pen. And we had different nibs. We had ABS, Teflon, and you could choose which kind of texture that you wanted in your pen. Yeah, so there's a lot of innovation in that piece of glass.
Apple's first proper laptops, called the PowerBook series, proved to be an excellent basis for new, more compact Scribe prototypes. They offered better performance and, coupled with some of the touchscreen technology that was being developed, yielded devices that began to really show what the Scribe interface was capable of.
Lori Bertelny did all the visual design on this, and a lot of the conceptual design as well.
Vertelny demonstrated the Scribe interface using one of Gilly's prototypes, which had been wrapped in black vinyl for the occasion at Apple's 1991 Worldwide Developer Conference.
So I have a stamp in my notebook for labeling page titles. I call it my table of contents stamp. And what I can do is open up my table of contents list. And what it does is brings forward into this box here all of the objects that I've marked with that stamp. So it's nice because it gives me an overview of all the things in my notebook that have that stamp next to it. But above that, I can use this particular view to navigate directly to that page in the book just by pressing on it. So it's an additional way to get to a piece of information. But when you bring in stuff from the outside world, such as Apple Ink, you may have a problem because you didn't create it in your notebook, and it may be a little longer than the page in the notebook. So what I'm going to do is take the page and scroll it up with my hand. And you see it continues to scroll until I stop it. Okay, so the nice thing about this is the computer knows I'm not writing, that I'm scrolling, and it knows when I'm flipping the pages, and it knows how to keep all those different actions separate. And as a user, it doesn't matter to me. That's how I want to interact with it. Okay, now I think there's one more thing I was supposed to show. Well, gosh, let me hit my remember stamp and see what it was. Oh, yeah, these are the people that helped build this notebook with me. That's it. Thank you.
You can't tell from the video, but the presentation was so well received by the audience that she got a standing ovation. But as clever as its interface may have been, Scribe wasn't really fit to become an actual product.
And so we set up a user test, actually having people hold it, and I think that was probably some kind of inventory taking task that we ran in our lab. In doing user studies, you almost never get a 100% response on anything, but we got 100% on this is too heavy. That's not going to work out well. But it was kind of astonishing how heavy it was, and it was heavy enough that holding it in one hand and writing on the other was really difficult, and that was very sobering.
In time, no doubt the hardware would have indeed caught up to become lighter and easier to hold, but touchscreens were a new concept to the general public, and some of the clever ideas the Human Interface Group had were perhaps just a bit too ahead of their time.
And when we had novel things like the page flip on Scribe, even though we thought, oh, that's wonderfully intuitive, we've made it look like a notebook. Clearly, people are going to think about, just dragging the finger across the screen. That was very hard for people to discover. They would try tapping on the edge of the screen, but most of them just didn't think of the gesture.
Ultimately, the biggest limiting factor was simply economics.
We were imagining it as a very limited functionality piece of equipment that would be good only in certain circumstances. We didn't envision it as a full-fledged computer that you would use everywhere. And I think early on we did some prototypes where we imagined Scribe being used for like inventory control, or Scribe being used to take notes in a meeting, or Scribe being used by accountants doing an audit at a client.
But the advanced hardware needed to make Scribe possible wasn't cheap. Full-fledged notebooks at the time were expensive. Apple's mainstream laptop from late 1991, the PowerBook 140, cost over $3,000 US. Scribe's price tag would have been even higher for a product that, while cutting edge, simply wasn't as capable. The marketplace wouldn't have bought it.
In technology company, a lot of the management and executives are either technologists, or at least they're very, very pro-technology. And anytime somebody comes along and says, this technology isn't very good, but we can compensate it by doing this, that's not a very popular stance. Because you'll have a lot of avid technologists saying, oh, we can make it better. or, oh, this is actually world class and it's good enough. That doesn't always pan out, and products that assume it does fail. On the other hand, it'd be a pretty hard marketing job to say, we've got this cool new device and it does have handwriting recognition, but since that kind of sucks, we've got this great great thing that will make it work well enough. That's a hard row to hoe, even though intellectually I think it's really fascinating, you know.
Scribe as a project was dead, but that didn't mean all the research would go to waste. Apple did still need a handheld computer, and touchscreen technology was a direction the industry was heading. What if, instead of a purpose-built device like Scribe, they revisited the original idea of a touch-capable Mac? A team deep within Apple had actually been working on handwriting recognition, and a new line of Apple laptops was being developed that would lend themselves to solve the problem of a tablet computer being too heavy or bulky. These ideas all coalesced into a new project called PenLite. Just like they had done with the Scribe prototypes made from PowerBooks, one way to cut costs was to reuse existing components and technology. And the guy instrumental in making this happen was Steve Young.
Tom was at an ATG, Advanced Technology Group, which was in the same building as me. We were in Valley Green 6. He was on the first floor and I was on the second floor. And I don't really know how we met, maybe at a beer bust. I'm not exactly sure, but we became really good friends.
Young was the project manager for Apple's second generation of laptops known as the PowerBook Duo.
So I was targeted with doing a really small computer, and I kind of became the architect for it. And it evolved up being the Duo. I said, let's take as many connectors off of it as we can. We'll make it as thin as we can.
The name was a reference to the docking stations that owners could use to turn their laptop into a desktop. That concept made perfect sense for a touchscreen Mac as well, so the Duo would prove to be the perfect foundation for PenLite.
And I don't know if we're out drinking or a beer bust or something, and somebody said, we should build a Duo that has a tablet, right? I was really close with the display guys because I'd done that earlier project. So we used to go to Japan to a company called Hosiden all the time. And then I asked them to do one that had a touch screen on it. Tom was really into doing something that was real, a product. He really wanted to do a product. I have a lot of respect for Tom. He's a great guy. And so I'm feeding him, Mac Duos, like, here's just some prototypes,
But Young went the extra mile to help out Gilly's project.
When he had his layout engineers create that motherboard for the Duo, he created a very secret set of pads on the bottom that broke out the second serial port. The SEC, serial communications controller, had 2 serial ports. That second serial port wasn't used on the Duo at all.
We did that so that there would be no barrier for Apple to say, oh, you guys can't do this, it's going to take forever. And like, no, it just uses a standard Duo board. Yeah. I probably got in trouble for that, but I didn't care. I didn't give a shit.
This is still when I was in the Advanced Technology Group, R&D, and hadn't moved over yet. And when he had those early boards, we demonstrated it working, and it was a major dust up because it was R&D working with product probably for the first time ever.
So that kind of changed a lot of let's work with these guys. Because they had they were super well funded. And the product guys, we had trouble we really had to justify it when we wanted to get our funding. So, I mean, I was joining the group and I said, Tom, you should be working for us. Like, let's make a product out of this, right?
Yeah, so I had to leave R&D and move into product group, and it became an official product based on that second serial port on the bottom of the Duo.
So, with PenLite destined to become a member of the PowerBook Duo family, Apple's industrial design group got involved in shaping what it would look like. The earliest prototypes were all handmade, many by Gilly himself.
There was a very large machine shop. All of the elements of that unit you have were milled out on Bridgeport machines there on Apple's campus. It was awesome to see.
But since it would need to work with the full range of Duo docks and accessories, it ended up taking on an appearance more familiar. Basically, a Duo with its screen flipped around.
Interestingly, if you open that thing up, there's a lot of airspace in that unit. It could have been a lot thinner, but we kept it thicker than it needed to be so that it would fit into the Duo dock. It wouldn't fit in the Duo dock unless it was that thick. It had to be that form factor.
Even though the design was pretty much a given, there was still a lot of work to be done to get it to operate as a tablet, with the bulk of the challenges coming from the touchscreen.
Putting a tablet on an active computer is almost impossible because of the RF interference. So we took one of the gantries for doing the milling, and we put the pen to test the tablet, and the tablet was on the computer. So we were able to measure all the distortions of the RF fields from the computer while we were testing the tablet, and then we used that distortion field in the manufacturing or the assembly of the computer, which was necessary to get as much resolution as we needed.
Of course, trying to reduce the amount of interference to begin with was really important in getting the touchscreen to be as accurate and responsive as it needed to be.
So what we did, which was really magic, and we worked with a famous engineer, Jim Williams, at Analog Devices, and he redesigned that inverter, which is taking low voltage and creating extremely high AC voltage. And he designed it so that it had almost no noise in any of the harmonic ranges of the graphics tablet, because that graphics tablet really is an antenna. It's an active pen that's emitting frequency, and then it's a transistor-based scanning matrix antenna. And that's why you could have multiple pens and multiple fingers in the future. We got the inventor to license it to Logitech. And so Logitech was the manufacturer of the final tablet and the pen.
A lot of thought and effort went into getting things right on the software side too, starting with the driver that got the Mac operating system to recognize the stylus as if it were the mouse.
We used the Kalman filter for predicting where the pen would be in the future. The person that told me about that was Alan Kay. He was a famous computer scientist.
Kay had been named an Apple Fellow in 1984 and was floating around various departments to offer his opinions on projects.
Smalltalk, Xerox, kind of the forefather of all the graphic UI. And I was demonstrating the pen to him, and he says, "Oh, that sucks," because it lagged so much. And he said, "You should take a look at the Kalman filter." And he didn't tell me anything more than that. I did the research. Kalman filter came from shooting down airplanes. You shoot in front of the airplane, not at the airplane. So it's the same thing with the pen. You can predict where the pen's going based on the velocity. And so we created a driver for the pen that made it feel like it was super responsive.
The big thing still was data input. They got a company called SoftAnswer to come up with an on-screen keyboard, and it worked fine, but who would buy a tablet computer just to tap letters in one by one? They needed to try the one thing that the human interface group thought wouldn't work: a handwriting recognition engine, codenamed Rosetta.
Rosetta was a skunkworks project, super innovative as a neural network recognizer.
That meant it could learn. The more you used the handwriting recognition, the better it would get at figuring out your particular style. And it fit in pretty naturally with the Mac interface.
You could start writing anywhere on the screen, and wherever the cursor was blinking, it would insert the text. It was a very innovative way of interacting with the existing operating system and the existing applications.
Performance wasn't great, but the nature of PenLite meant that most text input would be brief, and with the pace at which technology was progressing at the time, it would undoubtedly get faster. All that was left was to package it up as cost-effectively as possible. The motherboard was the same as those in the Duo 230, and in place of the trackball, a custom PCB was installed.
We had something we called the way board, and that was to deal with the polyimide flex to the tablet and the display.
Other than the display itself and the top housing of the machine, the majority of PenLite's parts were off the shelf from the Duo lineup, which saved money. Except for one small thing, a port on the top edge for a keyboard. No doubt some people would want to be able to type on it, so an external keyboard was designed as an accessory. But there wasn't an appropriate place to put a normal ADB port, since Duos didn't come with those built in, so they came up with a custom interface.
Of course, for Apple, we get to make our own connectors. It's kind of a rite of passage at Apple. No, it's literally, if you made a computer, you got to make your own connector.
A special carrying case was designed that allowed you to use PenLite while keeping it safely inside, user manuals were being written, and everything was looking good. The tablet Mac was ready to hit the market. Scribe and subsequently PenLite hadn't been Apple's only foray into handheld computing. There were at least 2 others running concurrently with it. Early on, Gilly's experiments with SmartEffects and tiny computers had caught some interest.
I remember, we're sitting in my office and he's getting it to work, and then Mark Peratt was a guy who, he was an advisor at Scully or something. He saw it and he said, can I make a product out of that?
Peratt, in fact, used this board when pitching his ideas about palm-top computing to Apple's board of directors. He won approval to proceed with development, calling the project Pocket Crystal. In a few years, his team would get spun out of Apple into a company known as General Magic, and a few manufacturers, including Sony, licensed its Magic Cap operating system. But another ongoing effort within the company proved to be a problem for PenLite. The Newton project had similar ambitions to Scribe to create a device that could help organize your life. But that team, led by renowned computer scientist Larry Tesler, didn't have the same reservations about handwriting recognition. In fact, they leaned on it heavily. Early concepts centered around tablet-sized devices, but Apple CEO John Sculley was convinced that a smaller, pocketable device was the way to go.
It's interesting because Apple then, I'm not sure about now, but it was very competitive between groups, between ATG groups, between product groups. I'd say my group was always the first, but then it would trigger then other groups to create, their own concepts.
So it was competition between Newton, Apple II, and Macintosh. And actually, Scully got a little pissed off about it, and he said, "We're one Apple. We're one company. Learn to get along."
That didn't seem to help much. The Newton team had sequestered itself away, so it was doing a lot of the development on its own, unable to fully take advantage of the work that ATG had been doing. The project dragged on and missed several deadlines. Newton's original ship date of April 1992 came and went, with the team scrambling to fix serious software bugs and hardware issues. A new deadline of late 1993 was set, and Apple poured resources into the project, money and people, to get it to succeed. But the team was getting burned out, and even Tesler, who had been Newton's largest advocate, was feeling the pressure. He didn't want his project to fail. Meanwhile, PenLite was basically a done deal.
So the software was released. The software's production. We had 2 versions of it, US and Japan. The first release was going to Japan because the handwriting recognition for Japanese worked better than for English. So we wanted to do another round on the software before we did the US release. So the first release was in Japan. We produced 500 units production. So there were FCC, UL, everything signed off, ready to go, and packaging for Japan.
But suddenly, Gilly had the rug pulled out from under him.
Just after that first 500 units, I think Larry Tesler got wind that we were in production and did a full court press to the board of directors. I was called in on that, and it was like that was a deer in headlights. I didn't know what was going on around me.
Gilly tried to explain how PenLite was different from Newton, which it definitely was, but to no avail.
That got lost and was largely my fault. I was so young, I really didn't know how to present it to, board of director level people to make that final decision. If I had presented it in a different way, more clearly and concisely, and disassociated itself from it being just a tablet and being more of an extension of your desktop, it would have seen the light of day.
Perhaps he shouldn't be so hard on himself, though. 1993 was a rough year for Apple. It saw mounting financial struggles in the face of stiff competition from PC manufacturers, the ouster of Scully as CEO after he failed to find a potential buyer for the company, and was facing layoffs. Apple needed to minimize risk. PenLite, while far more capable than what Scribe would have been, was still going to be expensive, with base models slated to sell for $3,500 US, almost twice as much as the equivalent Duo model. Newton, on the other hand, was priced at $700 and already had market interest stemming from a demo earlier in the year. There was only room for one touchscreen device, and Newton won. PenLite was dead.
When you're doing these things as a team, it's a team bonding experience, and because it's all-nighters and getting things done. And so as a release, I was announcing to the team that we've been canceled, and people are crying, and it was all emotional. And I said, okay, well, we're going to do our final drop test. So this was in City Center, and I think it was 9 floors in Cupertino. And I said, okay, listen, you guys can't go up there. I'm going to go up there, because I knew I was going to get in trouble. So I said, okay, everyone look out the window, and we'll do the final drop test. And so he threw it off the top of the building. It didn't survive, but it still booted. It wasn't in pieces. The glass was broken. The display you could still see. So people were really excited about that drop test. And yeah, I did get in trouble for that.
There was still the issue of the machines that had already rolled off of Apple's manufacturing line, though.
So it's debatable whether they were shipped to Japan or crushed. I would say at least 100 units made their rounds. We kind of distributed units. There were a bunch of pre-textured units, probably 10 that were shared. It went to production, but it was a very limited run before it was canceled, and then everything was crushed. It got all crushed. Everything, all the tests, everything was crushed, which is unfortunate.
And then it was a shame that they decided not to do anything with it, because if it would have been a Mac platform, there would have been a million apps for it. I mean, that was our argument on the Mac side, is like, hey, you get this pen device and you get the whole family of Macintosh applications, right? And they probably should have given it a try and released it.
But in various ways, the work ATG did for Scribe and PenLite wasn't lost.
Think of it as innovation that influences product, and it would have influenced General Magic, it would have influenced Kaleida, it would have influenced PenLite. While its entirety didn't make it into product, that wasn't their objective. That wasn't how they were being measured. They were being measured on innovation, how innovative they can be, forward thinking.
And that innovation helped save the next product Gilly worked on at Apple, a new generation of full-size PowerBooks known as the 500 series and codenamed Blackbird.
It's a wild story. So the actual team that did the design engineering, they all quit, all of them. It was empty. They went to Dell because Apple was going through so big. This is 93. I think AT&T was going to buy Apple. Sony was going to buy Apple. And Apple was in deep shit. It was a huge mess. And so they just canceled the PenLite. They said, oh, we want you to take this and get it into production, and the Blackbird, and everyone was gone.
But it had a problem. Its new solid-state pointing device, the trackpad, didn't work.
It was just like the filtering. It was a filtering issue. They couldn't get it to work. Matter of fact, we had a trackball as a fallback, and they were going to go to the trackpad. I said, no. We know what to do. This is noise. We know what to do. So we did the same techniques that we did on PenLite, and we just brought some good engineers in and resolved all the issues and got it out the door. Yeah, that was fun. I really enjoyed it. That was a great learning experience.
And as it turned out, at least a few PenLite units had indeed made their way across the Pacific. In September 1996, the Japanese publication PC Watch ran an article about Apple's presence at the World PC Expo in Tokyo. In the booth were a couple of PenLites, with Apple employees asking attendees to come up and write something on them. Their goal was to solicit handwriting samples to further enhance Rosetta. And in fact, Rosetta had been integrated into version 2.0 of the Newton operating system. Ever since launch, Newton's handwriting recognition received bad reviews and harsh criticism. But with the adoption of Rosetta, it got substantially better. Of course, years later, Apple would introduce the iPad, which, in many ways, was what Scribe and PenLite had set out to be.
Down at the team level, it was so exciting. It was a wonderful way to spend a career, and I did so many cool things. And then you finish something, and when you're in a big company as opposed to a small one, it sort of bubbles off, into the machine, to wildly mix metaphors. It's interesting to understand how the ecosystem of ideas and inventions and widgets works. Because, not very many people have, I think, the experience of, I create this thing and then it, everybody is using it, right? I think mostly stuff gets created, and does it affect things? Does it not? It's hard to say, and it's kind of in between.
I have great memories of working at Apple. I mean, it was really hard work. I mean, a lot of hours, a lot of good stuff, So I loved it. It really, and a lot of the people were just fabulous.
The idea of doing rapid integration to production was innovative, but probably the more mature Apple knows you got to take your time, and it's okay to let other companies play with MP3 players and phones, and then look at it, see what could be better, and then doing it better. I think with innovation, but not always needing to be the first out there. I think that's something that Apple learned. But yeah, it was an amazing time.